Welcome to another episode of Mr. Avila Physics. Today we're going to be talking about electric charge. Now, all materials are made of atoms, and in the simplistic model, the nucleus is made up of neutrons, protons, and electrons which orbit the nucleus. As long as the number of electrons is equal to the number of protons, then the charge of that atom is neutral. But if an electron is removed from the atom, then the atom has a net positive charge and becomes a positive ion. That means that there are more protons than electrons, so the atom has a positive charge. If an electron is added to an atom, then the atom is going to have more electrons than protons, and it's going to have a negative charge. Now, before we could look into the atom, there was a simple experiment done to prove this. Okay. Now, in this experiment, a plastic ruler was rubbed with a cloth to charge it, and at the same time, a glass rod was also rubbed to charge it as well. Okay. Now, when a second plastic ruler, which is also charged, was uh, was brought close to the first ruler, it looked like the first ruler was repelled by the second ruler. And the same thing happened with the glass, right? When a second glass rod was brought to the first glass rod, also a repulsive force seemed to act. But when the ruler was brought close to the glass rod, or the glass rod was brought to the ruler, then they found out that these objects can attract each other, as we can see here in the picture. Now, this led scientists to believe or to prove that, in fact, there were only two different types of charges. Okay? And it also allowed them to conclude that like charges will repel each other and unlike charges will attract each other. Okay? Now, by looking at charges as just positive or negative, we can look at this algebraically. So, and during any process, the net change in the amount of charge would be zero. So charges, electrons lost by one object would be gained by another object, and the total number of electrons between the two objects will remain constant. So no real change in charge would happen. This led us to one of the most important laws of physics, which is the law of conservation of electric charge. This law states that the net amount of electric charge produced in any process is zero. In other words, it means that no net electric charge can be created nor destroyed, only change from one object to the next. Now, how can charge be transformed or not transformed? How can charge be transported from one object to the next? Well, it usually needs a conductor, right? It usually needs a way to conduct, which materials can be divided into these three categories. Materials can be conductors, which easily transport electrons without trying to capture or impede them, such as wiring in your house or your electronic devices. Non-conductors or insulators, which impede the transfer of electrons, such as rubber boots or rubber soles or rubber gloves, things like that. And semiconductors, which are somewhere in between. Now, looking at a periodic table, metals are usually the good conductors, non-metals are good insulators, and metalloids are good semiconductors. So, how would this process work? Suppose that we have two metal spheres. One is highly charged and the other one is electrical neutral. If we place a metal object so that it touches both spheres, then the free electrons from the charged sphere will transfer through the nail into the uncharged sphere until eventually they both have the same charge and they balance each other out. If instead of a nail, we would use a piece of wood or a piece of rubber, then the free electrons of the charged ball would not move into the uncharged ball, like the picture suggests. In here, we can see that the free electrons here move through the metal to the neutral ball until both spheres have the same charge. But if we put a non-conductor or an insulator, then the charge just kind of stays in one of the spheres. Now, what are other ways of charging objects? There's charging by conduction, which is very similar to what we've just seen. In charging by conduction, let's say we have a positively charged metal object brought close to an uncharged metal object. If the two objects touch, then the free electrons in the neutral one will be attracted to the positively charged object and some will pass over to it. Now, as some of these electrons pass to the positively charged object, then the second object will have a net positive charge. All right, so charging by conduction or by contact, kind of like this. So we have a neutral metal rod, then we bring in a charged metal object close to it, and since this charged object is positively charged, then the electrons on the neutral rod will be attracted to this positively charged object, and some of them will cross over because they're in contact. Therefore, the initially neutral object will be missing electrons and will be positively charged. And then when the two metals stop touching each other, then both metals will be positively charged. Another way of charging objects is by induction. When we charge by induction, the objects come close to each other but do not touch each other. Now, since these two objects are not touching each other, then the free electrons of one object cannot jump into the next object, but they will still kind of pile up on one side of the rod, right? For example, we have something like this. We have a neutral metal rod, then a charged object is brought close to it, but not touching. So the electrons are going to be attracted to that positively charged, and the protons are going to be repelled by that positively charged. So then the initially neutral metal rod is now going to have an induced charge on one side and a separate charge on the other side. Now, if we add an extra step, then, okay, we can completely charge an object and give it a different charge. So the extra step is to ground this object. By grounding the object, it means we basically put a wire from the object to the earth. And since the earth is very massive, it can freely accept or give electrons easily. Okay? So that means that if we have the same thing, okay, we have a neutrally charged object connected to the earth, right, with this ground. We bring a charged object induced, let's say in this case negative instead of positive, just for kicks, right? Then the positive charges of the rod are going to be attracted to the negative side. The electrons are going to be repelled by the negative side and are going to go into the earth through this wire. Then when we cut this wire, then the remaining metal rod, which was initially neutral, will now have a positive charge. Okay? And this is a charge. Thank you for watching. See you in the next episode.